In this video, I am going to cover calculating molar mass, doing conversions between mass and moles, and then also calculating percent composition. So when we look at this first example, it says determine the molar mass of calcium nitrate. Alright, well when you look at this, we have to get the formula for calcium nitrate. And what you should notice is that it has a metal in there being calcium, and it has a polyatomic ion, nitrate. The way you know it's a polyatomic ion is because it ends in ATE. So you're not going to get that from the periodic table. What we want to look at is calcium has a +2 oxidation number. It is an alkaline earth metal. Nitrate, according to our polyatomic ion sheet, is NO3 with a -1 charge. So when you crisscross those oxidation numbers, you get Ca NO3 in parentheses with a 2 outside. So you have to make sure you get the formula right. You know it is not a covalent compound because it does not have any of the prefixes that we use for covalent compounds like mono, di, tri, tetra, penta, and so on. Okay, so now we have Ca NO3 in parentheses with a 2. And what you want to do is write down each element and how many you have of that element according to the formula. So there is 1 calcium, and you multiply that by calcium's molar mass off the periodic table, and I just round those to 1 decimal point. So it's 40.1. There are 2 nitrogens. You have to remember to distribute the numbers outside the parentheses to both things inside the parentheses. So that's 2 nitrogens, which are 14.0 apiece, and now there are 6 oxygens that are 16.0. Remember, you multiply those, you do not add them. So for the calcium, that's nice and easy, it's 40.1. The nitrogen's 28.0, and the oxygen, 6 times 16, gives you 96.0. And we add those up to get the molar mass, 164.1 grams per mole. So that's saying if I had 1 mole of it, if I had Avogadro's number of particles, 6.02 times 10 to the 23rd, I would have 164.1 grams of calcium nitrate. And for these, I'm fine with you going to just 1 decimal place for the molar masses. So 164.1 is good enough. Okay, now I'm going to scroll down and do some conversions between mass and moles. Alright, now I have 25.0 grams of sodium chloride, and then I have 2.50 moles of sodium chloride, and I want to do conversion. So again, we have to get the formula for this. We know it is not covalent because there are no prefixes like mono, di, tri again. So this is going to be an ionic compound. Sodium has a +1 charge. It's an alkali metal. Chlorine is a halogen. It has a -1 charge, so you get NaCl. There's no subscript, so this one's pretty straightforward to get the molar mass. There's 1 sodium, and sodium is 23.0 off of the periodic table. There is 1 chlorine, which rounded off to 1 decimal point is 35.5. And you add these up and you get 58.5 grams per mole. So again, if I had 1 mole of sodium chloride, I would have 58.5 grams of it. But the problem is telling me that I have 25.0 grams of NaCl. Now before I even do the math for this, 1 mole was 58.5 grams, but I only have 25 grams. So I have slightly less than half. So I should expect my answer to be slightly less than half of a mole. Alright, so if I set this up, 25.0 grams of NaCl, since I start off with grams of NaCl, they go on the bottom. I'm looking for moles of NaCl, so mole goes up top. The number 1 always goes with moles in the conversion factor when we're going from grams to moles. And the molar mass that we calculated over here, the 58.5, that's what goes on the bottom in this case. So on your calculator, what you're going to do is essentially 25.0 divided by 58.5, and that'll give you 0.427 moles of NaCl. And this is about what I was expecting, since the molar mass is 58.5 and we only had 25 grams to start with. I was saying it was about a little less than half a mole, and that's what we got, 0.427 moles of NaCl. Now pay attention to significant digits. 25.0 has 3 significant digits. So we have to round our answer off to have 3 significant digits, and that's what 0.427 has. Now for the next one down, it is the same compound. It's sodium chloride, so that's going to save us a little bit of work because we already figured out the molar mass of it. Start off with the number I gave you, 2.50 moles of NaCl. Get into the habit of writing both the units and the compound or element or molecule that's being used. Now since I started off with mole goes on the bottom, moles of NaCl, and it's always 1 in the conversion factor. And we use the molar mass we already calculated, 58.5 grams of NaCl. So now on your calculator you do 2.5 multiplied by 58.5, and that should give you 146 grams of NaCl. Again, this is 3 significant digits, the number we're given in the problem, so we round our answer off to 3 significant digits. Remember, you never use the conversion factor to figure out significant digits. They are said to be exact numbers. There is no uncertainty there, so they have an infinite number of significant digits. Now what I'm going to do is go down and do a percent composition. Percent composition, most of a percent composition problem is doing the molar mass. So we have to figure out the formula again for this. Now, there's a metal, which is magnesium. You have a polyatomic ion, that is phosphate. So this is another ionic compound. So you have magnesium. Magnesium is an alkaline earth metal. It has a +2 oxidation number. We have phosphate, which is PO4 with a -3. So when we crisscross these oxidation numbers, you get Mg3. PO4 goes in parentheses with a 2 outside. So, do this molar mass first. The magnesium, there's 3 of them according to the formula. Its molar mass off the periodic table is 24.3. You multiply that out, you get 72.9. Phosphorus, there's 2 of them. Again, remember you have to distribute the 2 to both things inside the parentheses. So there's 2 phosphorus, which are 31.0 apiece. So that multiplies out to 62.0. For the oxygen, there are 8 oxygens at 16.0 apiece. Multiply that out, gives you 128.0. Add all this up, 262.9 grams per mole. That is the molar mass. Now, whenever you do a percent, remember it's always a part divided by a whole. Well, these 3 numbers that we just calculated, the 72.9, the 62.0, and the 128, are the 3 different parts of this compound, and this 262.9 is the whole. So what you do is divide each of those numbers, each of those parts, by 262.9. When you do that, you are going to get a decimal. All you have to do is move the decimal point 2 places to the right, which is really just multiplying by 100 to get your answer. For the percentages, I'm fine with you rounding off to 1 decimal point. So this is saying out of that magnesium phosphate, 27.7% is magnesium, 23.6% is phosphorus, and 48.7% is oxygen. And that is the percent composition of that compound.